Hello everyone, my name is Devashish Roy. I'm the head of training and development department at the Indian Cybersecurity Solution, and I welcome you all to this special webinar today. And today's topic is a very interesting one, that is route redistribution between different routing protocols like OSPF, EIGRP, and BGP. So in different enterprises, you can have different routing protocols running because nowadays we do not use the static routing anymore. We use the dynamic protocols. But let's say there are different routing protocols. So how to do the redistribution? What do you mean by that? So let's begin. So we'll be talking about the route redistribution between the OSPF, EIGRP, and BGP, and we'll understand the mechanisms of route distribution across different routing protocols. Now, what is route redistribution? Route redistribution facilitates the exchange of routing information across different routing protocols. Like if you are using different routing protocol, let's say OSPF, EIGRP, or EIGRP, BGP, OSPF, BGP, different routing protocol A's or the autonomous systems, then how to connect? Can you connect between different routing protocols in a simpler way? Means straightforward way? You cannot do it. So you have to redistribute, means you have to inject routes of one routing protocol into another. This integration is crucial for ensuring seamless communication between diverse network segments and improving network efficiency, because it is needed, because in every routing domain or every enterprise the protocol is different. You cannot say that every enterprise has to use OSPF or every enterprise has to use EIGRP or BGP. That cannot be the rule. They have their own protocol, their own domain, and they will not change it. So you have two choices. Either you can go for static routing or you can go for redistribution. So it is better to go for redistribution because there you can keep the existing infrastructure intact. Now we'll understand the open shortest path first, because we redistribute mainly between OSPF and EIGRP now. Now, what is an OSPF? It facilitates router communication. OSPF enables routers to exchange information about the connected networks because it's a link state routing protocol, and it has got the complete picture of all the routers, that is the neighbor routers connected, allowing for efficient path calculation and network convergence. Then hierarchical structure with areas it has. So OSPF uses areas to divide networks, means it wants to divide the autonomous system into different areas, because autonomous system has a lot of LSA. And if you do not divide those autonomous system into areas, then it will create a lot of LSA flooding. And it helps in reducing routing overhead and improves scalability by limiting the scope of routing updates. Then fast convergence and adaptability. With OSPF, routers can quickly adapt to changes in the network topology, and it provides fast convergence times, and it minimizes the downtime during the network failures. So OSPF is a very robust protocol. Then security through authentication. OSPF supports authentication mechanism that enhance security by ensuring that routing information is exchanged only between trusted routers, and you can also configure authentication or authorization. That is, the OSPF supports plain text authentication as well as the MD5. So now we will understand the EIGRP, Enhanced Interior Gateway Routing Protocol. It was Cisco's routing protocol for a long time. So what are the features of this? It has unique composite metric. So first of all, EIGRP is considered as an advanced distance vector protocol or hybrid routing protocol because it uses two metrics. One is bandwidth, another is delay. So EIGRP utilizes a unique metric called the composite metric, which combines bandwidth, delay, load, reliability, and in some cases MTU, but it doesn't use those. It uses mainly the bandwidth and delay to determine the best path calculation, and by default bandwidth. Then route summarization support. EIGRP supports route summarization, which allows for the aggregation of multiple routes into a single route advertisement. So you are actually combining multiple routes into single one. That is a route aggregation or route summarization. and EIGRP supports that. OSPF and BGP also supports that. Then rapid convergence capability. EIGRP provides features like rapid convergence, which actually allows for quick recovery from link failures. By rapidly recalculating the routing tables, it has topology table, it has neighbor table, it has routing table. So from the, let's say, the topology table, it recalculates the routes and it ensures minimal downtime. Now you'll understand BGP, or the Border Gateway Protocol. BGP is completely different. It is known as the Path Vector Routing Protocol because it uses many metrics or many vectors or many paths like that. So that is why it is known as Path Vector Routing Protocol, and it is preferred protocol in the ISP, not in the enterprise. That I was telling you, ACE path attribute. This is the first metric that it uses to select the best path, because OSPF uses cost, as we know, EIGRP uses bandwidth and delay, but BGP not a single metric. It has a lot of metrics. First is ACE path. BGP uses the ACE path attribute to prevent routing loops and determine the shortest path. Means routing loop means in the eBGP. So what happens? External BGP, you just have the ACE path information. So what happens? If the data is actually carrying, it is circulating from one router to the other router, then it is never coming back to the same ACE because it carries the ACE number. This attribute lists the autonomous system that a route has traversed, and it provides transparency in routing decision. Then policy-based routing. BGP employs a policy-based routing mechanism that allows network administrators to control route selection based on various attributes such as local preference and multi-discriminator MED. Now, policy-based routing, it is a feature which is actually the router does the routing based on the destination address lookup. But in the policy-based routing, it does the routing based on the source. So we can actually select different attributes or change attributes to make the router do the routing decision based on source, not on the destination. Now it has IPv4 and IPv6 support both. This protocol supports both IPv4 and IPv6, and it ensures that it can handle routing for a wide range of IP address and future-proof network infrastructure. TCP connection requirement. Definitely, BGP is based on the TCP. BGP requires a TCP connection for reliable transmissions for its messages, and it ensures that updates and routing information are delivered accurately and efficiently. Now, the need for route redistribution is there. Route redistribution is crucial for enabling communication between disparate routing protocols like OSPF, EIGRP, and BGP. It ensures that routing information is shared across different network segments, so it supports route redistribution as well, like the EIGRP and OSPF. Now, we'll talk about the OSPF to EIGRP redistribution, and also we will see it practically. So we have to understand the process of sharing OSPF routes with EIGRP. Now, how to do it? First of all, identify OSPF routes. Now, determine which specific OSPF routes need to be redistributed into EIGRP. So, if you have some loopbacks, so you can redistribute it. That is the redistribute connected. You can give the command redistribute connected, or otherwise, you can also redistribute other networks into OSPF. Let's say you have 10 networks in EIGRP, you can redistribute into OSPF and vice versa. Configure EIGRP router. Now, setting up the EIGRP router to enable the redistribution of identified OSPF routes. That should be the ABR. One should be the area border router, which connects between the EIGRP and OSPF that you have to set up. Then implement route maps. If you want to say change the criteria of the redistribution, or if you want to filter out some routes, then you can do it if you can change some metric. Otherwise, you do not need to implement route map. Route map is like the ACL, but it is say a very advanced ACL, utilizing route maps to filter and control which routes are redistributed. So that I've already told you. If you want that filtration, then you need to have the route maps. And you have to verify the distribution. You have to check the configuration to ensure that the distribution process is working as intended routes are being shared correctly indeed. So this is the process to actually redistribute between EIGRP and OSPF or BGP or any other routing protocol. So that is the theory part of the redistribution. So I hope that you have got the knowledge about what is the distribution and how to do the distribution, but you have to do it practically. So for that, now let us go to the GS3, and as you can see, I have three routers running: router 1, router 2, and router 3. But let them start. So I'm starting the routers, and now I will go to each router's console. R1 is F0 by 0 to R2's F0 by 0 connected, and R2's F1 by 0 port is connected to R3's F1 by 0 port. So we will give IP addresses, and then we will say have some loopbacks. We'll have some loopbacks, and then this router R2 will be configured as the ABR, area border router. So let's start by clicking on the R1. So go to R1 and go to the interface F0 by 0, no shut, and give the IP address, let's say 1001, and default mask, and also create loopback 10001 and the loopback address. Now go to R2. This will be the ABR, area border router, as well as you can say the ASBR, autonomous system boundary router, because it will connect between EIGRP and OSPF. In the fastener 0 by 0, no shut, and give 1002. And on the other router, let's say the F1 by 0, you give no shut, and let's say the IP address is 2001. Now go to the R3 quickly and go to the F1 by 0. No shut, and IP address is 192, or not 192, it should be, I have to check what is the IP that I'm providing. It is 2001, so here it would be 2002 itself. And here you create a loopback. The address should be, let's say, 20001, and the default mask for now I'm using. Now that is the IP address that is configured, and what you can do, you can, let's say, configure EIGRP on this router 1, router EIGRP 1, network 0000, and on R3 you configure total OSPF, router OSPF 1 or any other process ID, and again you have network 0000 and 255 255 255 255 and area 0. And now you configure the ASBR, like in R2 you are running with EIGRP on the F0 by 0, that is on 1.0, and on 2.0 you are having the OSPF. So go to the R2, go to router EIGRP, yes, number 1, network you are running 1.0.0.0. Wildcard mask is not needed here. You can give, but it is not needed. Give exit and see the relationship is established. Now router OSPF side 1 and network 2.0.0.0 255 by 5 area C. So it will establish the relationship with the R3 with the OSPF supported router as well, and it has already done. Now you need to redistribute from the OSPF to EIGRP and EIGRP to OSPF. So router OSPF 1 redistribute, then EIGRP 1 give question mark, and you can specify metric type, either say external type 1 or 2. I'm not doing it now. You can specify NSS special area, or you can implement route map, or you could implement subnets. Now, if you give subnets, it means that the classless networks will be redistributed. But here I'm using the default mask, so it is not needed. So that was the distribution of EIGRP into OSPF. And now the opposite thing. Router EIGRP 1 redistribute OSPF side 1. And now if you want to redistribute something into EIGRP, then you have to specify the metric. Remember this thing. Metric. What are the metrics you have? Bandwidth, say 1000 kbps. Delay, say 255. Then say reliability, say 255. Say effective bandwidth metric load, that is 255. And MTU, say let's say 1500 byte. So all these K5 values you have to specify. And now you have redistributed between the EIGRP and OSPF successfully. So let's check. Now let's go to the R1 and give show IP route. You can see some external routes in the EIGRP that is specified by EIGRP external, that is 2.0 and 20.0. You can also filter it out with show IP route EIGRP. You can see the external routes specified that EX. And you go to the R3 now and you give show IP route and then OSPF. You can see that external 2 or E2 route, OSPF external type 2 route, is advertised here with 1.0 and 10.0. So external 2 route means that it is adding the cost. When it is coming to the interface, then it will add the cost. External type 1 or E1 route, you can change the metric type. So what will happen? Then when the route will be advertised, it will come to the interface, the cost will not get changed. But it is E2 route by default, so the cost gets updated or calculated or added. So this way you can redistribute, and the R2 is acting purely as the ASBR autonomous system boundary router. The same way we can configure BGP, AS, and also redistribute into BGP. But in case of EIGRP only, you have to specify the metric, not the other protocols. So that is the thing. I have shown you how to configure the distribution between OSPF and EIGRP, and similarly you can also achieve the distribution. Just configure BGP and also give the redistribute command into the BGP autonomous system. So that way we configure the redistribution between the routing protocols. That is a very important feature of your Cisco studies. So I have shown you practically also how the redistribution is achieved between the routing protocols, and also I've discussed theoretically between the OSPF, EIGRP, and BGP routing system how to achieve the redistribution. Now this redistribution, let me tell you, it is a very important feature in routing protocols, because as I've told you, routing is not so much done. So it is done by purely the distance vector routing and link state routing and path vector routing protocols. And it is very important for your Cisco studies for CCNP, NRC, and ENCODE, and also for CCNA studies. So I thank you all for joining this webinar once again. I hope that you have got immense knowledge from this. And I have a very good news for you. There is a contest running, and I have prepared a question that is having 10 questions. If you can give 8 questions out of 10 correctly, then you will be eligible for certificate. So that's a great news. Just think about it. So you must go for this, and you must give the answers correctly right now. And also, you'll be eligible for the 10% flat discount on courses if you enroll for today. So I urge everybody to enroll yourself for this course now. I'm a senior trainer of the network, and I take personally the CCNA, CCNP courses, and I can definitely recommend that you should go for these courses and enroll yourself for this CCNA, CCNP networking training right now, because this training of networking is the ultimate that is regarded in the Cisco platform. And if you are going to plan your career on the Cisco networking, these CCNA, CCNP certifications are absolutely must for you. So if you're an say certificate aspirant or any network engineer, this is a must for you. And this skill, this redistribution, it has no other choice because you have to learn this in order to get certified and also in order to be a very successful network analyst or network engineer. So I hope that you will be able to incorporate the skills in your network engineering as a network engineer or network analyst in an enterprise or cloud domain or in the ISP network. So that is it about the route redistribution between OSPF, EIGRP, and BGP topic today. And I hope that you have got a good knowledge on this and it will help you in your future studies of Cisco networking as well. So that is it from me on the topic today. I will come with some new topic next time. Till then, keep studying and bye.